With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello students, let us have a look at the question first of all. So the question is of paragraph type, which says that paramagnetism is a property due to the presence of unpaired electrons. In case of transition metals, they contain unpaired electrons in the n-1 d orbitals. Most of the transition metal ions and their compounds are paramagnetic. So they are trying to convey us that most of the transition metal ions and their compounds are paramagnetic due to the presence of unpaired electrons in n-1 d orbitals, right? So they are also adding that paramagnetism increases with increase in number of unpaired electrons. Yes, that we can say just by looking at the formula of a magnetic moment, which is mu is equal to under root n into n plus 2 Bohr magneton, where n is the number of unpaired electrons. Now, if n will increase, magnetic moment will increase, and hence eventually the paramagnetic moment, the paramagnetism of ion or a compound is going to increase, right? Now, they're also telling us about the color of the compounds of transition metals that can be attributed to the presence of incomplete n-1 d subshell, right? When an electron from a lower energy of d orbital is excited to a higher energy of d orbital, the energy of excitation corresponds to the frequency of light absorbed. So what happens that on the attack of a ligand, right, d orbitals splits into two energy levels according to crystal field splitting theory. So if there is an electron in the lower energy level, that is T2G, right? So sometimes it takes energy from the visible radiation and it gets excited and promote itself to a higher energy level, that is EG, and when it returns, it emit the absorbed energy in the form of visible radiation, right? So this frequency generally lies in the visible radiation, they are saying, yes, or visible region. Now, the color observed correspond to the complementary color of the light observed. Now, they are saying that the frequency of the light absorbed is determined by the nature of the ligand, right? So, the nature of the ligand will determine the frequency of the light that is absorbed. Now, they are asking us a question to solve based on this particular paragraph, that titanium shows magnetic moment of 1.73 Bohr magneton in its compound. What is the oxidation state of titanium in the compound, right? And we have been provided here with 4 options and we need to find out the correct one. So to solve this question, first of all, we'll have to write down the formula of magnetic moment that we have seen in the paragraph, that is mu equals under root n into n plus 2, right? Now, mu is given to us, that is magnetic moment is something. We have been given 1.73, right? So 1.73 equals under root n into n plus 2, right? Now, we can square both sides. So squaring both sides will be getting 1.73 whole square equals n into n plus 2, right? Now let us try and solve this equation. So we have n square, I'm just reversing the sides, so n square plus 2n equals, so 1.73 will be equal to 2.9929, right? Now, this 2.9929 can also be taken as equivalent to 3, right? So to make it our calculation easier, now let us take the value. So it will be a quadratic equation. So n square plus 2n and minus of 3, right? So 3 will be 3 will come this side and it will be minus of 3 equals 0, right? Moving on. So we can write this as n square plus of 3n minus of n minus of 3 equals 0, right? N can be taken common here, n plus 3, and plus 1 could be taken common here, which will become n plus, which will make it n plus 3, right, equals 0. Now n plus 1 into n plus 3, right, equals 0. Now we will be getting two values of n, so n will be so it's minus of 1, right? I've done a small mistake here, so it's minus and minus, right? So n will be equal to 1 or minus 3, right? And minus 3. So minus value will be discarded, obviously, because n is the number of unpaired electrons. We can't have negative value. So n will be equal to 1, right? Now n equals 1 means that it has one unpaired electron left in its d subshell. So to find out the oxidation state, we'll have to write down the electronic configuration of titanium. So titanium with atomic number of 22 will have the electronic configuration as Ar 18. Then we have 3d2 and 4s2, right? Now only having one electron left means titanium will have to show the plus 3 oxidation state, right? So 2 electrons will be taken out from s orbital and 1 from d orbital. So it will make titanium plus 3, and it will have the electronic configuration of Ar 18, 3d1 and 4s0, right? Now it has one unpaired electron, which means the value of n is 1. Now let us observe the option that we have. So we have plus 2 plus 1 plus 3 and plus 4. So plus 3 is the correct one, and the remaining 3 are incorrect. So this is how we can solve this question. I hope this is clear to you. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubt and App today.